Welcome to this third tutorial in which I'm going to be developing Kevin Kennedy's fantastic custom nameplate from his Product Design Online YouTube channel. So Kevin did this just as a basic 3D model for 3D printing. I've developed this into the idea of having kind of a glass effect 3D text LED light. So following on from the first two video tutorials that I've created for this, what I want to do is look at doing the sweep on the text and also then shelling the text, because what I want to happen with this light is make it so that the text isn't solid, the text is actually shelled, which means that the light from LEDs underneath this 3D print will shine up through the text and it will glow. That's what I'm looking for. So let's have a see. I've got my nameplate, I've got my text on here, everything's been dimension driven to the right size, and I've got this sweep arc on the side here. So, or sweep profile, should I say. So let's go ahead now and do the sweep. Or before I do, let's just see what I've got down the bottom here. Let's just look at my history, okay? So with my history marker here, I'm going to bring this back to the start where we began. And the first thing I did here was I created the sketch. Let's make sure that my sketches are all visible. There you go, that helps. And I made sure that this sketch had very specific dimensions, and I talked about why I was choosing these dimensions so it would fit on the 3D printer and I could do multiple prints at the same time. Then let's just finish the sketch there. Then we did an extrusion of this to make sure that we have a very, very thin base. We don't want a big, thick, chunky base, which is what Kevin has. We want a very thin base because we want the light to shine through this, and we're trying to save the amount of filament to be using because we're going to have an acrylic laser cut base for this, which is going to mount the LED lights. So this doesn't have to be that strong. It just needs to be very, very subtle and allow plenty of light to come through. Then we have the text going on, which is very carefully scaled so it fits nicely on the base. And then finally, we're going to have this sweep arc profile. Okay, let's go to let's go to sweep. Here's my sweep dialog box. It's going to be a single path. And as Kevin says, we're going to have as the profile is going to be the text here, and then the path is going to be the path that we created there. And this brings the text all the way up so it is vertical, which looks really, really cool. But unfortunately, we won't be able to do this on a 3D printer. Now, Kevin kind of talks about this with a little bit of detail. In fact, something just happened that I'm going to show you, which I really, really enjoy. Can you see that when I'm viewing it in 3D, we have the full 3D perspective? You can see the text here looks like it's going to a vanishing point somewhere over here, so it's fully 3D. But when I click on this left work plane, it suddenly snaps into an orthographic view, so everything is flat on. And I can also see loads and loads of lines in here as well. So let's just see what's happening here at this point. First of all, let's go to, I think let's go to display settings. And let's go to, I've got to think where it is now. Is it visual style? Oh my goodness. I should have done, I just should have made some notes about this first, shouldn't I? Oh, there we are, camera, that sort of one. Okay. If I go with perspective all the time, then you can see, even with this left view shown, I can see the depth of the object. I can see the design going to basically this is a 1-point perspective. Let's just zoom into it. It really is 1-point perspective. So the vanishing point is right in the middle of this shape. So everything in this drawing is leading back to a vanishing point somewhere back here. Okay, if you to draw these perspective lines back, you go to a vanishing point. And of course, if I rotate this into 3D, we still get my perspective effects. Let's instead here go to the orthographic view, and this means that if I view this from this left work plane, it's represented as a flat 2D profile, which is what I want because it really simplifies my drawing experience. But if I just bring this into 3D, now it looks really distorted, and that's because the height of the D at the front here is the same as the height of the N at the back, but our brain is telling us that in 3D things get smaller as they move away from us, so it really distorts the image. We've lost all perspective effect. What I like to work with the camera model here is perspective with orthogonal faces, which means that in all of my 3D views, it's representing this as a 3D effect with perspective. But if I view this from a work plane, we have got it as an orthogonal view. Everything is flat on. Okay, so now I can see that I'm seeing this as a flat face to edit. Okay, right. So enough about that. Oh, what else did I want to show here? I've also got all these lines in here. Let's just see what's happening here. If I go to visual style, at the moment I've got shaded with hidden edges. If I go to wireframe with hidden edges, then now you can really see what's happening. It's showing all of the profiles of these 3D extruded shapes, and if it's visible, it's solid, and if it's hidden, it's dotted, which looks really, really cool, but gets a little confusing if I'm viewing this as a orthogonal sketch profile from one of these work faces. So let's go to visual style, let's go to shaded, and I like to go with visible edges only, and then it really kind of highlights these edges. You're welcome, of course, to explore some of those other settings. Notice as well, I can still see the sketches through my drawings here. What I might want to do here is turn off the sketch view, and now I can just see. And interestingly, I can still see the text there. Oh, I know why. I can still see the text because I'm using the text as part of this sweep command. Okay, now uh, back to our main point here. Kevin was saying that you need to be aware of the properties of the 3D printer in terms of support material when you're building. And if I have a look at this, the problem is occurring right here where my mouse is currently moving, because as this is building out, you can imagine that the 3D printer is basically extruding all of this filament, and as it builds out roughly from about this point onwards, we have this overhang, and this overhang is working towards a horizontal overhang. Any filament extruded out of the print head at this point is just going to drop away. It's just going to fall away unless there's some scaffolding, some support material placed in here, and that's not very good. It's okay at this point though, because technically we could remove this support material, even though it would give a bit of a poor finish. But it's more of an issue up here inside the model, because if this is going to be a shelled piece of text, then up inside this model, there's going to be support material appearing in here. And trying to dig that support material out when it's inside the text is going to be pretty much impossible. So what we cannot do is build this with support material. But if we build it without support material, the whole thing's going to collapse if we're working with a standard fused deposition modeling 3D printer, which is what the Zortrax printer is. Okay, so solution is I'm going to come to this distance command, and I'm going to put that to 50%. Now, before I dial it in, remember that 100% or one hole was a 90 degree sweep. So if I put it to half a sweep or 50%, then logically you realize it's going to go to 45 degrees. Let's put this to 0.5, and I've now got a 45 degree sweep. Now this is going to be perfectly acceptable. That will print nicely, but you might think that the text isn't quite sticking up enough. Let's see what I've got here, what I've got there. Here I've got the text sticking up more, okay? I think I've got this, let's see, I've probably got this to maybe 66 or 70 degrees profile. Okay, well, what I'm going to do now is do a little bit of maths, okay? What I need to make sure here is that in this extrusion, and let's just bring in 2D design here. In this extrusion, I've got to make sure that whatever, whoops, that was not a straight line, that was a fail. Whatever I do here, I'm going to put a line on here. Let's see. Let's just take that line. That's what I'm going to do. I'm going to take that line. I'm going to come to transform. I'm going to rotate this, and I'm going to rotate it through increments of 10 degrees. Let's do this, and I'm going to repeat this a total of 9 times. Okay, I'm going to repeat it around at that point there. Okay, there we are. So now what I've got are our increments of 10 degrees. Let's just confirm that is the case. Okay, whoops. I'm going to come to my dimension line tools. I'm going to put angular dimensions. So let's have a look. That command, that one there is going to be, let's bring that back to there. That's going to be 10 degrees. This one here is 20 degrees. This one here is 30, and so on and so forth. Okay, you get the idea. In fact, I'm probably just going to delete those back now because I don't need those. Okay, in fact, no, actually, I will keep them. I'm going to take them all the way to there. Okay, let's just dial in these values as well. Have I got enough space? Just about. Okay, and I'm going to add in that line. I'm going to add in a line. Yes, I'm going to add a line there. Oh, that's genius. Ho, 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 ho. You'll see why in a second. Okay, right. So the key thing is here that when we're 3D printing, anything that is below this line, in terms of a kind of a build out here, is going to collapse. Okay, anything below that. So as we're building out a design here, let's just zoom in on this. Okay, and let's just now imagine that we're building something out. So the 3D printer here is going to be building, building along, and it's going to build up and then along and up and along. And at this point, it's going to be perfectly happy to build like this, even though we've got these kind of step outs here. It's not so extreme that it's going to collapse. But if I start to build here and build along to here and follow this 20-degree line, that will collapse. Basically, what we're saying here is that the length of that distance there is okay. It says 13. Ignore that value, but that is too extreme, and the filament will basically collapse away. But anything that's beyond this 30-degree measurement, let's just come to properties here, and I'm going to really make sure that that line there stands out, and that text is bold. Let's just do that there. That is the magic there. That is the point at which above this angle we're going to print successfully. So you might think to yourself, well, I can any height above this is going to be fine. Well, let's just look at this from a different perspective. What I'm going to have here, in fact, you know what? I said it was a genius idea to put a line there. I'm actually going to put a line. I did that line wrong. I'm going to put a line here. Okay, that's the line that I want. Okay, is that right? Come on, brain. Work, brain, work. No, I was right the first time. Let's just see what's going to be happening as I extend this up, okay? I've said it's going to be 30 degrees here. The same applies for the text as it's coming up. Basically, I'm going to suggest that, 90 minus 30 is, of course, 60. Here's our 60-degree line. I'm going to suggest that this line here is the maximum height that we can extend the text to, or the maximum angle we can extend the text to. Let's make that a different color. Let's have that green there, okay? And that's going to be this 60 degrees. Let's bring that to the front, and let's just also make sure that that is going to be a nice thick line too. Okay, let's make that green as well. Okay, and let's make that text bold. Okay, there's another. Oh, and green is disgusting. I can't see the text at all there, but there you go. Why did I change that? Why did I change that? That was a ridiculous thing to do. Okay, but this green line here is really the height we can go, and it's all to do with what's happening here with the overhang. In fact, let's just bring in a circle here, and let's do an overhang like this. As soon as that's what I want to show, as soon as we get an overhang here, can I get a dimension here? I don't think this is going to work. If I try and get a dimension between there and there, no, that's not going to work, okay? But I can kind of come into this, and I can try and pick up the kind of intersect there. There's ways I can do this, but I'm not going to worry about it. Let's pick up that intersect. Let's try and get that dimension there. This is coming in at 21 degrees, and that is less than 30 degrees. So that basically means that here, again, within the 3D print, we're going to be getting support material required as this builds out like this. And again, this value here from that point to that point is going to be too long for it to go. I had that down as 13. I've got that down as 6, but believe me, it's too long. So all of that to basically explain here that when we bring this text up, I'm going to close calculator. I don't want that. Let's just come back to this sweep. I'm going to right click on it. I'm going to edit the feature. When I'm building this up, I need to control this angle. In fact, I do want calculator, because using calculator, what I'm now going to do is work out how this 0.5 affects the angle. Okay, so maths, I love it. Okay, in calculator here, I'm going to take 90, okay, and I'm going to multiply that by a half. And we know that if I put it to a half, it's going to be 45 degrees. Now, what happens if I want to put it to 60 degrees? Okay, well, let's have a see. If I put 90 here, and I'm going to multiply that by 0.6, let's try that, because you think 60 degrees, that should be 0.6, but no, it's not, because it's not 100 multiplied by 0.6, it's 90 multiplied by 0.6, so that'll be 54 degrees. Okay, so let's think about this. 60 is 2/3 of 90, so if I do 90 multiplied by 0.66666666 recurring, then that gives me 59.999999994. So that's almost there. Okay, well, I'm going to try something else here. How about I do 90, and I want 2/3 of 90. So therefore, I'm going to divide it by 3, gives me 30, and then multiply that by 2. Now that gives me 60. Okay, now how about in here? I could put 0.66666. I could do that. That would be 60 degrees. And we know from my calculations here that 60 degrees, actually 60 degrees to the vertical there, no, that will be fine. Okay, my tangent there, in fact, look, I did the tangent at 70. Okay, at 60 degrees, that would be absolutely fine. In fact, let's just prove that right now. Let's come into here. I was struggling here, wasn't I? Let's try and do a tangent at that point. I wonder here, can I actually do, let's see, can I do a tangent? Let's come to here. Can I do a tangent from a line? Okay, let's do this. What's it asking me to do? Locate point on arc or circle. Okay, so is it going to be there? Yeah, look at that. That's amazing. Oh, and has that worked? Oh my goodness. Let's see. Let's go to the angular dimension. Let's take this back to here. Is that going to be 30? Okay, it's actually slightly off. It's because I just misclicked there, but that's pretty cool. I like that. So we know that 60 degrees is going to be fine, but I know that this is slightly off. I know that this, remember, this is going to give me well, it gave me 59 point something or other. How about instead I replace that with 2/3? Does that work? So I can use fractions to define distances in Fusion 360. I didn't know you could do that. That's so cool. Okay, that looks absolutely awesome. Let's just confirm that there, and there's my text looking really cool. Okay, now this has been an epically long video, but I'm just going to conclude this now because we're almost there. I'm going to do 2 final things. No, I won't. I'll stop, and I will do one more video. It's going to be better. Let's stop there.